Hi guys, welcome to the 5.6 quadratic formula video. In this video I'm going to show you how to factor and solve for the roots of a quadratic or a trinomial using the quadratic formula. So if you remember from class, we actually learned a song to remember the quadratic formula. So that's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So say that over and over again until you remember the entire quadratic formula. But the way that you use the quadratic formula is when you've tried all of the other methods, or you notice that you can't find the two numbers that will add to be b and multiply to be a times c. So when you can't find the two factors, you can use the quadratic formula. But in order to use the quadratic formula, you have to have the trinomial in standard form. And we know that to be ax squared plus bx plus c. So that we have our highest exponent first, then our next highest, which is just the x value, then the lowest exponent was just a 0 at the end. So we have to make sure that it's the x squared, and then the x value, and then just a number at the end. So you're going to get actually 3 possible solutions, and the solutions that you can get is no solution, and that's when you have a negative under the radical. So if you want to write this in your notes, a negative under the radical. One solution would be when you have a 0 under the radical, and 2 solutions would be when you have a positive number under the radical. So that's when you can have those 3 different kinds of solutions. And we actually call this radical, or this part of the formula, which is the part that is the square root of b squared minus 4ac, that is called the discriminant. And you're actually going to get a question like this on the EOC that's asking you, using the discriminant, tell how many solutions you will get. So you're going to plug in your b squared and minus the 4 times the a times the c, and whatever number you get, whether it would be negative, 0, or positive, will tell you 0, 1, or 2 solutions. All right, so let's take a look at an example. All right, so for number 1, you first have to see if it's in standard form. So it is in standard form, ax squared plus bx plus c. So then we're going to list all our a, b, and c, which is a is 1, b is 10, and c is negative 2. So then we're going to plug in using our quadratic formula. So the opposite of b is negative 10, plus or minus the square root. B squared would be 10 squared, minus 4 times a, which is 1, times c, which is negative 2, all over 2a, which is 2 times 1. And then you're going to simplify and use the order of operations. So we're going to do 10 squared, which is 100. Negative 4 times 1 times negative 2 is a positive 8, all over your 2, when 2 times 1 equals 2. Then you can combine your 108 and get 108. And there's 2 ways to solve this. You can actually simplify the radical, and I'm going to show you that way, or you can solve and get an actual decimal 2 answers. So remember what I said from the previous page, that if you get a positive answer under this radical, so under the radical, that radicand is positive, so we're going to have 2 answers. And so let's go and do the 2 different ways. So you have negative 10 plus or minus. And you're going to want to think of all the ways that can multiply to equal 108. But here on the right-hand side, you'll notice that, I didn't want to do that. You'll notice that this is all of the perfect squares up to 10. So in your calculator, if you put 108 and then hit divided, and you just go through all of these until probably 49, you could stop and see what is the highest number that you can get to that will give you a whole number answer. And the one that you want to use is actually 36, because when you put 36 in, you get 3. If you put 49 in, you get a decimal. So we don't want to use 49. So when you put 36 in, it's 3 times 36, and we can actually take the square root of 36. So that was the whole point of that. So if you take the square root of 36, the 6 comes out, the 3 stays under, and then we're just going to copy everything that we didn't use. So let me show that again. So square root of 36 is 6, and the 3 stays under the radical, so we write that there. And then we're copying down the negative 10 plus or minus, and all over 2. So that would be the answer if they don't want a decimal. If they want a decimal, then you need to go back to here, and in your calculator, you're going to put in the square root of 108. So you can write down that decimal and just plug it in each time. So -10 plus or minus what that decimal is divided by 2. And when you do the plus version, you get 0.19615. If they don't tell you to round, I always say 4 or 5 decimals is enough. And you don't have to do all, 10 that are in your calculator or however many there are. And then if you do -10 minus square root of 108 divided by 2, you get -10.19615. So if it's asking you for the decimal, then you'll have to use this at the bottom. If it's asking you for, the radical, then you'll want to use this one right here. So you can either get either one of these two answers, depending on the question and how it wants you to answer it. All right, let's move on to number 2. All right, so for number 2, you have to ask yourself, is this in standard form? Is it an ax squared plus bx plus c form? And it is not. So we have to get rid of that 4x so we can make it equal to 0. So we're going to subtract 4x because right now it's a positive 4x. So then we're going to make sure when we rewrite it that we put -4x in the middle because that's our b term that we're moving to the other side. So x squared minus 4x minus 11. There. And then you're going to do your a, b, and c. So a, b, and c would be 1, -4, and -11. And use your quadratic formula. So remember, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. All right, so opposite of b would be a positive 4. Plus or minus the square root, b squared is -4 squared, minus 4 times your a, which is 1, times your c, which is -11. All over 2a, which is 2 times 1. So now we're going to use order of operations and solve for our two answers. So we're going to take -4 squared, which is just -4 times -4. So that's 16. -4 times 1 times -11 is a positive 44. You can use your calculator to remember to make sure you're accurate. And then 2 times 1 is 2. So now we can combine the 16 and the 44, and you get 60. So 4 plus or minus 60 over 2. So again, we can break that 60 up into two different numbers, one being a perfect square and the other being a not perfect square. So if you don't remember from the previous page, our perfect squares just come from doing 2 times 2, which is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is your 64, 9 times 9 is 81, and 10 times 10 is your 100. So that's where all your perfect squares come from. So I know that 60 minutes has 4 groups of 15. So if I take 4 and 15, I could take out the 2 and leave the 15 underneath. So, let me go back one. I'm going to get rid of the perfect squares for a second because that ends up being a problem on the next part. All right, here we go. So 4 plus or minus, and we're going to use 4 and 15. So if we take the square root of 4, that becomes the 2 in the front. The 15 is not a perfect square, so it stays underneath. So we have 4 plus or minus 2 squared of 15 over 2. So remember, that could be one of your answers. Or if they ask you to do the decimal, you're going to go back to this version, which is your 60, and put the square root of 60 in your calculator. So 4 plus the square root of 60 divided by 2 is 5.87. 4 minus the square root of 60 divided by 2 is your -1.87. So depending on what they want, you could have two different kinds of answers. The decimal answer or the radical answer. All right, so for number 3, ask yourself, is it in standard form? And in this situation, it is not. So we need to subtract 20 on both sides. And make sure that you put 20 at the end because that's the c value of your ax squared plus bx plus c. Then you're going to list your a, b, and c. So we have a equals 1, b equals -8, and c equals -20. So the sign to the left of each number comes with it when you do your a, b, and c. Then you're going to plug it into the quadratic formula. So the opposite of b is 8. Plus or minus b squared would be -8 squared. And then minus 4 times a times c all over 2 times a, which is 2 times 1. Now we're going to use the order of operations, so negative 8 squared is 64. Negative 4 times 1 times negative 20 is positive 80. And 2 times 1 is 2. So now you can combine like terms with 64 and 80, and you get 144. Well, I know 144 is a perfect square because that's 12 times 12. So if you take the square root of 144, that turns into 12. So now we can set up our two answers. 8 plus 12 divided by 2 is 10, and 8 minus 12 divided by 2 is negative 2. And so those are your two answers. All right, so for number 4, is it in standard form? Yep, it is. So we can keep going using your quadratic formula. So you're going to do a, b, and c, which is 1, 6, and 10. Plug it in. So we have the opposite of b, which would be negative 6 this time, plus or minus b squared, which is 6 squared, minus 4 times a times c, which is 4 times 1 times 10, all over 2 times 1, which is your 2a. And you're going to use the order of operations to solve for your two answers. So we get negative 6 plus or minus the square root of 36. Negative 4 times 1 times 10 is minus 40, all over 2 times 1, which is 2. So we can combine 36 and negative 40, and you get negative 4. So we know that if that radical is negative, we automatically know there are 0 solutions. So we're going to say no real solutions, and we're done. Because in Algebra 2 is when you're going to learn how to do imaginary numbers. In Algebra 1, you don't have to worry about them. So for all your own purposes, you need to just write no real solutions when you get a negative under the radical. All right, number 5, is it in standard form? It is in this situation, but if you notice, there's something missing. So we're actually missing the b term. So when we're missing a term, we can just use 0. So when we write our ABC, we're just going to write b equals 0. So now we have the opposite of b, which the opposite of 0 is just 0, because you can't do negative 0. Plus or minus 0 squared is your b squared, minus 4 times a times c, so that's negative 4 times 2 times negative 8, all over 2a, which is 2 times 2. So now we're going to solve for our two answers. So you have 0 plus or minus, 0 squared just turns into 0, and negative 4 times 2 is negative 8. Negative 8 times negative 8 is a positive 64, all divided by 2 times 2, which is 4. So now we're going to solve for those two answers. When you combine 0 and 64, I just rewrote it as 64. We know that 64 is a perfect square, so if you take the square root of 64, it turns into 8. So our two problems are going to be 0 plus 8 divided by 4, which equals 2. And 0 plus 8 divided by 0 minus 8, divided by 4, which equals negative 2. And those are your two answers for number 5. So number 6, same thing. You have to ask yourself, is this in standard form? So you're looking at ax squared plus bx plus c, and the 12x is on the wrong side, so we need to subtract 12x to the other side. So make sure when you rewrite it that negative 12x goes in the middle. So you have 4x squared minus 12x plus 9. Then you're going to list your a, b, and c. So 4, negative 12, and 9. And then you're going to plug it into the quadratic formula. So the opposite of b is 12. Should I sing the song one more time? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You're welcome. Okay, so the opposite of b is 12. Plus or minus b squared, which is negative 12 squared, so that's 144 when we rewrite it, minus 4 times a times c, so that's minus 4 times 9, all over 2a, so that's 2 times 4. Then we're going to use the order of operations, so we have negative 12 squared, which is 144. Negative 4 times 9 is also negative 144, and 2 times 4 on the bottom is your 8. Well, 144 minus 144 is 0, so we're actually not going to add or subtract anything because the square root of 0, remember, from the beginning of the guided notes, I said if the radical or the discriminant is equal to 0, we have only one answer. So 12 over 8 is our answer. We can simplify that, though, into 3 over 2. And if you need it as a decimal, 3 divided by 2 would also be just 1.5. And that would be the final answer for number 6. Go Seahawks!